Welcome back to the Cisco NetAcad CCNA Switching, Routing and Wireless Essentials lecture series. If you haven't seen my previous lectures, I will leave a link in the description for the playlist. I would also recommend that you watch the Introduction to Networks lecture series before you move forward with this course. Today, I will cover module number 13, which is WLAN configuration. In this module, we will learn how we can implement a WLAN using a wireless router and a WLC. We will cover remote site WLAN configuration. We will learn how to configure a basic WLAN on a WLC. We will also learn how we can configure a WPA2 enterprise WLAN on the WLC. Finally, we will also cover how you can troubleshoot common wireless configuration issues. This lecture is a little bit lab heavy. However, even though I am going over these lectures with the theory part, with some diagrams and images for the lab part, I will post separate videos on the labs so that you have a better comprehensive understanding of the topics that we're going to cover today. Remote site WLAN configuration. There's a video titled Configure a Wireless Network available on your Cisco NetAcad or through your academic institution. If you have access to Cisco NetAcad, please go ahead and watch this video. If you do not, I will post a copy of this video onto my YouTube channel, and I will leave a link in the description of this video as well as a card on the top right hand corner. I would recommend that you watch these videos because this will cover the topics that we will cover in the next few slides. The wireless router. Remote workers, small branch offices and home networks often use a small office and home router. These integrated routers typically include a switch for wired clients, a port for an internet connection, sometimes labeled as WAN, but also sometimes labeled as internet, and wireless components for the wireless client. These wireless routers typically provide WLAN security, DHCP services, integrated name address translation, also known as NAT, quality of service, also known as QoS, as well as a variety of other features. The feature set will vary based on the router model as well as the device manufacturer. So if you get a small home router or office router, they probably have all of these integrated functions built into it. From it is acting as not only a router, but it also act as a wireless switch. And it also provides the connectivity to outside, and sometimes these routers are integrated into your broadband modem. So you could have a router modem combination at your office or home as well. So that's another option that may be available to you at your work site. Please note the cable or DSL modem configuration is usually done by the service provider's representatives either on site or remotely. So all the configuration that you need to connect to the ISP should be provided by your ISP themselves. So on the right hand side, we have a diagram here provided to us by Cisco. You have an end user that is connected through a wireless router to the broadband modem. And then the broadband modem is handling the internet connection between the internet and the local system. And on here we have a picture of a Cisco wireless router modem combination. It's basically a Cisco router with the wireless capabilities. Again, depending on the manufacturer and the model number, the number of antennas associated with this device, and the ports associated with device, and the looks and feels of it may be differ. So don't just think that all wireless modems, wireless routers look like this. Log into the wireless router. So most wireless routers are pre-configured to be connected to the network and provide services. Wireless router default IP addresses, usernames, and password can be easily found on the internet. Therefore, your first priority should be to change these default security defaults for security reasons. Those includes the security settings as well, because default security settings are not good either. So to gain access to the wireless router's configuration graphical user interface or GUI, open a web browser and enter the default IP address for your wireless router. The default IP address can be found in the documentation that came with the wireless router, or you can search on the internet. I also found you can find the default IP addresses and password for the configuration GUI can be found on the back of the wireless routers. So sometimes it sticks on the back of the router or the wireless access point, or on the bottom of the device. Typically, they are located near the model number and this SN number, the serial number. And that would be your default configuration. The word admin is commonly used as the default username and password for many devices by multiple manufacturers and vendors, but it is not always the case. Also, another note in here regarding default settings. If you take a device right out of the box, it will most likely have those default settings. But however, if your service provider or somebody provided you with a device that may be used by another person or have been already set up, and you have no way to figure out what is a username and password, there may be a reset button. Typically, most devices have a reset physical button on the back of the device or sometimes front of the device. And you can hold down that button and that will reset everything back to default settings. That includes the default username and password for the web GUI. So if you forget your username and password, or somebody hand you a device that already has been set up and nobody knows the username and password for the web GUI for the default settings, and if you don't mind losing all the settings that they have done, you can simply press that button and hold it, so that will reset your settings back to your default username and password. So that's another note that you should remember. So how do you set up a basic basic router? It doesn't need to be wireless, any router. So the first thing you need to do is to log into the router from the web browser, change the default administrative password for security reasons. That will log you out of the system. So you're going to log back in with that new administrative password after you have set it up. Change the default DHCP IPv4 addresses to whatever the addresses you would like to have. Renew the IP address. Then you can log into the router with the new IP address. So these are the basic settings of any router that you're going to set up that you can go through. Whether it's a wireless router or wired router, you should go through these steps. Basic wireless setup. So if you have a wireless router, after you go through the initial settings I have mentioned on the previous slide, to set up your wireless, you can go through these steps, right? So they include view the wireless LAN defaults, such as SSID, the security settings, other defaults may be associated with your specific model and version. Change the wireless mode, identifying which 802.11 standard is to be implemented. So it's based on your network environment, your requirement, you can change those settings. Configure the SSID, which is the ID that will be associated with your wireless network. Like for example, Manuja.net or home network or office network, whatever you like to have on the SSID, you can configure there. Configure the channel, ensuring there are no overlapping channels in use. So as a network administrator or a system administrator or a network technician, you should configure manually those channels and making sure that there are no overlaps on the channel settings. However, in 2022, most modern devices, most wireless devices come up with an automatic configuration that will make sure that there are no overlapping channels, especially consumer grade, consumer high grade devices that being sold out by the consumers. They don't actually need to go into the channel settings. It will automatically pick by the system itself. But as a system administrator, network administrator, you should configure the channel and ensure that no overlapping channels in use, even if they are automatically picked for best use by the device itself. The reason why I'm saying this, because that's why these companies are paying your network administrators and network technicians to do their job, right? So as I mentioned again, most newer Cisco devices, as well as many other manufactured devices, especially consumer grade devices, will automatically ensure there are no overlapping channels in use. However, as a network technician, and especially when you are using enterprise devices, you should ensure there are no overlapping channels in use during your configuration. And then you should configure the security mode, selecting from open, WPA, WPA2 personal, and WPA2 enterprise, etc., etc. And you should also configure the paraphrase, also known as a password, as required for selected security mode. So when somebody try to connect to your SSID, your wireless network, the password need to be set here so that that password will be asked whenever somebody try to connect to your system. And again, these are things as a network technician you should always go through. But as a home user, you may be able to skip some of these steps right out of the box when you set up your wireless network. Now we're going to look at how you can configure a wireless mesh network. So in a small office or home office network, one wireless router may be enough to provide wireless access to all the clients. If you want to extend the range beyond approximately 45 meters indoor and 90 meters outdoor range of a typical wireless network, you can create a wireless mesh. Create the wireless mesh by adding access points with the same settings except using different channels to prevent interference. So you can put multiple APs within your network with the exact same settings, the wireless settings associated with each other, such as encryption type, the authentication type, the name of the SSID going to be exactly the same, but you're going to you will change the channel settings so there won't be any overlaps. In this example, they are using channel 1 in this access point and channel 11 in this access point, so there won't be any overlaps. The reason why we are doing this is that this will still create a mesh network, interconnected mesh network, but prevent interference between different APs. Extending a wireless LAN in a small office or home has become increasingly easier as newer, more intelligent devices coming into the market. Manufacturers have made creating a wireless mesh network, or also known as WMN, simple through smartphone apps. So even Cisco consumer devices and some enterprises devices have smartphone apps that you can simply go through the settings and it will interconnect multiple access points in a mesh environment by following few simple steps. D-Link and other service provider, other manufacturers also have their own mesh systems. TP-Link, D-Link, Cisco, they all provide these smartphone apps for home users who can simply use those smartphone apps to configure their mesh network with multiple access points. Another one I have seen also, even without a smartphone app, some providers such as D-Link, I have seen their mesh devices, they have physical buttons on their APs, and you can connect all the APs together in a mesh system. Let's say you have 3 APs, you need to put it on 3 different floors at your house. You can simply press all those buttons all together at the same time or within a certain period of time, and it will automatically interconnect with each other. It will sometimes also do the auto configuration for overlapping issues of channels and auto configure SSID and everything based on your main mesh device. So that's something to keep in mind. But as a network technician, again, as a network administrator, please make sure if you ever use these automatic configurations or these smartphone apps, you go back and make sure that there are no interference and you've done it properly, or else that your client will be really mad for paying a network administrator or a network technician to set up something with overlapping issues. So don't trust this app. I don't trust this app. Even if it is provided by Cisco themselves, I always make sure on the other interfaces such as these GUIs or even through CLI to make sure that there are no overlapping issues within these automatically configured networks. NAT or Network Address Translation for IPv4. Typically, the wireless router is assigned a publicly routable address by your internet service provider and uses a private network address for addressing on the LAN or local area network. To allow hosts on the LAN to communicate with the outside world, the router will use a process called Network Address Translation. In short, it is called NAT. So NAT translates a private or the local source IPv4 address to a public or global address. And the same process in reverse would happen for incoming packets. So that basically means if you have a device on a IPv4 environment locally and you are trying to access the internet, it's going to translate your packets with your local IP address into the global outward facing internet address to communicate to the outside. And when the websites or whatever the resource that you are trying to access from the internet send packets back to your device, what's going to happen is those packets are going to reach the global facing IP address of your router or the modem in this case, and which was provided to you by your ISP. And the network address translation will again translate back that global data into your local IP address, or global IP address into a local IP address. So the primary purpose of the NAT is to translate private source IPv4 address to public global addresses. And when the public global address receive packets back into translate into the private local address. So that's why the primary purpose of network address translation. NAT makes sharing one public IPv4 address possible by tracking the source port numbers for every session established by a device. If your ISP has IPv4 enabled, however, you will see a unique IPv6 address for each device, and you would not need the NAT because we have enough IPv6 addresses available for everybody. Remember, in my previous lectures, as well as on my previous series, which is the Introduction to Networks lecture series, I describe how NAT works and why we use NAT. So if you don't remember, recall that the whole purpose of NAT or network address translation is to try to prevent the IPv4 address exhaustion that we are going through right now. So basically NAT allows us to still have enough global IP addresses for everybody around the world while still providing multiple device access within a local area network. Because local area IPv4 addresses are not globally routable, you can have many hundreds of local LAN IP addresses behind the NAT while outside facing one single IP address for the international or global communication. So your ISP may provide a single IPv4 address for outward facing internet, or maybe 2 or 3 IPv4 dedicated IPv4 addresses. But internally, you can have hundreds of IPv4 addresses for your LAN, like such as a small office, and that would be fine because we have the network address translation, and we basically trying to prevent the IPv4 address exhaustion globally by using NAT. So again, recall this from my previous lectures. For my previous lecture series, I have gone through this. So if you don't remember, please go ahead and watch my YouTube videos on that. Quality of service or QoS. Many wireless routers have an option for configuring quality of service. By configuring QoS, you can guarantee that certain traffic types such as voice and video are prioritized over traffic that is not time sensitive, such as email and web browsing traffic. On some wireless routers, traffic can also be prioritized on specific ports. Again, I have gone through a little bit more in depth on how quality of service works and how it is important on my previous lectures. You can go ahead and watch that. But for now, for this module, what you need to remember is that quality of service can be used to prioritize voice and video traffic because they can have any latency. So there may be latency issues on your network, and if that would impact the voice and video traffic. So QoS can mitigate that. And on some wireless routers, the traffic can also be prioritized on specific ports, but also can be prioritized on specific applications. Some smart next generation firewalls and routers can also have quality of services that can prioritize based on specific application as well. An example of a situation as a network administrator you may want to do that would be, let's say you are in a company that use a specific application to access a certain database outside your local site, right? So how can you make sure that services get the priority? Well, you may be able to use the QoS with those advanced features capable devices to make sure that application can reach that database outside as always. But however, typically in a home environment and most small business environment, QoS is used to prioritize voice and video traffic. And on here, on the bottom of the screen, you have an example of a QoS setup on a Cisco device. And we see the QoS priority listing with the IP phone being the number one high priority. And then we have the Counter-Strike and Netflix. This Counter-Strike is a video game. And Netflix is online streaming service with high priority with FTP and internet web traffic under medium. And other traffic, for example, this one under low, quality of service priority. So what the priority is doing, again, to make sure those time critical data packets get switched at the very first convenience over the other packets. Because IP phones, for example, would not work properly if the quality of service is not properly implemented. Port forwarding. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. So it is a security feature that typically built into most wireless routers. However, there are situations when specific ports must be open so that certain programs and applications can communicate with devices on different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. And a little bit about port forwarding also. This is not just associated with wireless routers, but also associated with typical even wired routers. An example of a port forwarding situation where you need to open a port would be, let's say you have a web server behind the router and you want people using port 443 or port 80 to access that web server from outside your network. You have to port forward the port 80 and port 443 so that it will get properly open for traffic. Otherwise, the outside users outside of your network won't be able to access your web server. So that's a very good example of port forwarding. So I used to have my Manuja.com website run out of my parents' basement. I used to have that set up so that the port 80, this is like 20 years ago, 15, 20 years ago, so that the port 80 is always open. Then, those days port 443 SSL is not very popular, but that do bring a vulnerability to your internal network. So how I mitigate that is to put my web server on a different VLAN with a demilitarized zone, DMZ. But again, I will go into depth of network security on a different lecture. This is just an example of why would you actually need port forwarding, a real world example, running a web server, for example, right? So that's what I'm trying to explain here. So there's a packet tracer file called configure a wireless network. If you have access to this packet tracer file, please go ahead, download it and do it. If you do not, I will find a copy and post to my website, and you can download there and go do that particular activity, and that will enhance your understanding of the concepts that we have covered. There's another packet tracer lab activity called configure a wireless network. Again, if you do not have access to this lab, I will post a copy to my sanuja.com website, so you can go ahead and download it and do it. And I will leave a link in the description of this video to that packet tracer file download location, so you can do them for your understanding of the concepts that we have covered. Now we're going to look at how we can configure a basic wireless LAN on the WLC. Again, there's a video called Configure a Basic WLAN on WLC available on your Cisco NetAcad. If you do not have access to this video, I will post a copy to my YouTube channel, and I will leave a link in the description of this video, as well as a card on the top right hand corner, so you can go ahead and click it and watch it. WLC topology. The topology and addressing scheme used for this topic are shown in the figure and the table. So if you look at the figure on the right hand side, you have the topology right here, and you have the information associated with the configuration for this topology. So we have two PCs, PCA, PCB, and we have a router, we have a switch, we have a WLC, we have access point, and we have a device. And we have the device information, interface information, and associated IP addresses and subnet mask on this table. The access point, or AP, is a controller-based access point as opposed to an autonomous access point. So it requires no initial configuration and is often called the lightweight APs or LAPs. And remember, I went over that in my previous lecture. So if you don't remember, please go ahead and watch my previous lecture. That will explain the differences. The LAPs use the Lightweight Access Point Protocol, or LWAPP, to communicate with a WLAN controller, also known as WLC. Controller-based APs are useful in situations where many APs are required in the network, because you have the ability to do central management through one single WLC for all of those APs, right? So as many APs are added, each AP is automatically configured and managed by that WLC. So for many home environment, you don't actually need this type of setup, but any corporate environment or office environment, this is a really good setup because you have the centralized control through WLC for all your APs. So remember this diagram, the network diagram, and you can also remember this. You can probably take a screenshot if you like right now, because the next few slides we may discuss this a little bit in detail. Login to the WLC. Configuring a wireless LAN controller, also known as WLC, is not that different from configuring a wireless router. The WLC controls the access points and provide more services and management capabilities. The user logs into the WLC using the credentials that were configured during initial setup. And remember, if you don't remember the WLC username and passwords, there may be default password usernames associated with it. Check your manuals or check the back of the device and you should be able to figure that out. or the other option is to Google search it, right? The network summary page is a dashboard that provides a quick overview of configured wireless networks, associated access points, also known as APs, and active clients on Cisco devices. So on Cisco WLCs, the summary page, which is the main page when you log in, will provide some basic data associated with that device. So in this case, Cisco 3500 series wireless controller. And then when this system administrator or network administrator logged in, and the first page they see, the home page, will have some quick overview of the configured wireless settings. You can also see the number of rogue access points and clients as well. So it will also show some additional data on the main page of a Cisco WLC, because other WLC home pages maybe slightly differ. View AP information. On a Cisco device, the Cisco WLC, you can click the access points from the left menu to view overall picture of the AP's system information and preferences. So on the right hand side, so the network summary is the main page. Underneath it, you can see the access point. When you click on it, this is the information you get. The AP is using IP address 192.168.200.3. You know this because it is displayed right here, IP address 192.168.200.3. Because Cisco Discovery Protocol, also known as CDP, is active on this network, the WLC knows that the AP is connected to the fast Ethernet 01 on the switch. So on the switch, it is using the FE01, and it knows automatically because it is using the CDP. This AP in the topology is a Cisco 1815i, which means you can use the command line and a limited set of familiar iOS commands. So it also allows command line interface interaction between the device and the administrator, because this particular Cisco device 1815i support that capabilities. Advanced settings. So most WLCs will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, a network administrator should be able to access more advanced settings. So as you are a network administrator or you are a network technician, you should be able to access those advanced settings and configure them, because that will give you more capabilities and flexibilities within your wireless network. For Cisco 3504 wireless controller, you can click the advanced in the upper right hand corner. So if you on here, you have the upper right hand corner, you have the options for advanced, and in the upper right hand corner you have the summary page, which is right here on the right hand side. You have the summary page after you click on that advanced option from the upper right hand corner. So it's not showing here the advanced options here, but how to get to advanced option, but you see the summary page of the advanced section. So from here you can access all the other features of the WLC, such as you can have the statistics on that CDP, you can configure the controller, you can configure security, you can change the management interface information and IP addresses. You can also set up much more advanced setting within each of these sections in this advanced configuration mode. Again, as a system administrator or network technician, you should be familiar with these advanced options for whatever the device manufacturer or a device type that you are using. But in this course, we are focusing on Cisco devices. I will go through them on a live lab demonstration in a separate video that I will post to my YouTube channel. Configure a WLAN. So the wireless LAN controllers have layer 2 switch ports and virtual interfaces that are created in software and are very similar to virtual LAN interfaces, also known as WLAN interfaces. Each physical port can support many access points in the wireless LAN. The ports on the WLC are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple APs. Each AP can support multiple WLANs. So if you want to know what are trunk ports and what are access ports and etc., again, please go and watch my previous lecture videos. I'm not going to go through them right now. But what you need to understand in this particular module is that each physical port can support many APs and WLANs, and ports on the WLC are easily essentially trunk ports, and that can carry traffic from multiple VLANs. Because remember from our previous previous lectures, the trunk ports can carry multiple VLANs, and each AP can support multiple WLANs. So these are key features that you need to understand in this course. And in the previous modules, we have covered how trunk ports and other things work. Okay. So if you don't remember, go ahead and watch that on my YouTube channel. So basic wireless LAN configuration on the WLC can be done by following few steps. You need to create a WLAN, apply and enable WLAN, select the interface, secure the WLAN, verify the WLAN is operational, monitor the WLAN to make sure that the operation is going correctly, and view wireless client information once the wireless client information is gathered after they have been connected to your network. So here we see some screenshots of Cisco WLAN configuration. So very first step we take, as I mentioned, is to create the WLAN. So in this figure, a new WLAN with the SSID name wireless_LAN is created. On the right hand side, you see the SSID right here, WLAN_LAN. And typically I also put the same preferred name and SSID because the preferred name is used, sorry, not preferred name, profile name. The profile name is used to identify this WLAN you just created within the configuration interfaces, sorry, configuration GUI. So I would use the same profile name as the SSID name, so it is easy for the next network administrator who's logging into this web GUI to identify which SSID that they are working on. So that's why they are doing here as well. So what your end user gonna see is the SSID name, not the profile name. Profile name is for us system administrators, network administrators who are logging into these GUIs, so we can figure out what network that we are working on. So typically I put the same, so that's what they are doing here. So the SSID is the what gonna get broadcasted out or being used by your end user. Next, what we're going to do is to apply and enable the WLAN. So next, the WLAN is enabled and the WLAN settings are configured. So how that's going to happen is you're going to hit apply and you will be greeted with this screen for configuration for that SSID and the profile you just created. And in here, what you need to do is you need to enable it by clicking off this, checking off this thing, and then you're going to click apply. Next, we're going to select the interface. The interface that will carry the WLAN must be selected from the interface down here, the interface options down here. And in this case, they have pick one. And then we're going to secure the WLAN. To secure the WLAN, you can go onto the security tab right here, and you're gonna enable whatever the security you're gonna use. In this case, we're gonna use PSK, and we're gonna get a strong password associated with that, and then we're gonna hit apply. So here, yeah, you don't need to apply right away. You don't need to click apply right away here, but you can. That's what I do sometimes. You can go through all of this setup, and then finally you can click apply as well. Again, I will go through these labs on a separate video and I'll post to my YouTube channel. So number 5, the 5th steps we're going to cover is to verify the WLAN is operational. So the WLAN menus on the left is used to view the newly configured WLAN in its settings. So if you go back to WLAN as main section, and if you go into WLAN section, you will see the newly configured one. So right here, we only have one configured with the profile name and SSID the same, which is the wireless_LAN. And then next thing we're going to do is to monitor the WLAN. The monitor tab is used to access the advanced summary page and confirm the WLAN now has one client using its services. So in right here, what Cisco has done, they gave us a screenshot with a situation where one client currently now connected to this. So if you just configure this SSID, you may not have any clients connected right now, so you need to be proactive and connect one client or few clients through this WLAN network and see if it shows up on your monitoring page. So that will confirm a proper working system. Finally, you can view the wireless client details. So if you have a wireless client now connected, you can go on the left-hand side in the monitor tab, and you can click on the clients option, and on that clients option page you will see the client associated IP address, the DHCP IP that has been given out by the AP, as well as the MAC address associated with that end device. Therefore, that you confirm this system works. There is a packet tracer file called configure a basic WLAN on the WLC. If you have access to this file, please go ahead and do it. But if you do not have access to this file, I will try to find a copy of this file and post it to my YouTube channel. Configure a WPA2 enterprise WLAN on the WLC. There's a video titled Define an SNMP and Radius server on WLC on your Cisco NetAcad. If you have access to this video either through Cisco NetAcad or through your academic institution, please go ahead and watch them now. If you do not, I will post a copy of this video to my YouTube channel, and I will leave a link in the description as well as a copy of that video on a card on the right hand side of this video. This will give you an overview of what we are about to cover. SNMP and radius. In this diagram, the PCA is running a simple network management protocol, also known as SNMP, and remote authentication dial-in user service, also known as radius server software. The network administrator wants the WLC to forward all SNMP log messages, example traps, to SNMP server. The network administrator wants to use a radius server for authentication, authorization, and accounting, also known as the AAA services. Users will enter their username and password credentials, which will be verified by the radius server. The radius server is required for WLANs that are using WPA2 enterprise authentication. Please note, SNMP server and radius server configuration is beyond the scope of this module. So I will cover SNMP server and the radius server configurations in a separate video that is not associated with this particular lecture series, so that you have a comprehensive understanding of all the components here. But for now, we are just looking at how we can configure a WPA2 enterprise WLAN on a WLC using SNMP and radius. So we are not going to go into the detail of that because you will not be quizzed, or there won't be any questions associated with setup of SNMP and radius in this lecture series. Please remember this network diagram on the right hand side, with the PCA having the radius and SNMP server, and the PCB and the wireless device that is connecting to the network through the switch 1, and the WLC and router configuration. So basically this network diagram will be what we will use for the next few slides in the setup of our WPA2 enterprise. Configure SNMP server information. So on your WLC, we need to enable SNMP and configure it. To do that, we're going to click on the Management tab to access a variety of management features. So right here on the WLC, on the configuration page at the top, you have the Management tab. So there are a few other tabs here. We look at Monitor tab in the past slides. So in here, we are going into Management tab. That's the first thing we're going to do. Next, we're going to click SNMP to expand the submenus. So you have the SNMP main menu, and you can click on it and it'll expand the SNMP sub options. Then we're going to click trap receivers. So right here we have the trap receivers. Then we're going to click new to configure a new SNMP trap receiver. So right here we're going to click new, because if you go to SNMP and if you go to trap receivers, there are no SNMP trap receivers configured right now. So we're going to create a new one. And we're going to click here new. When you click new, you will be greeted with this screen where you have the community name, IP address, status, and whether you're going to use the encryption of IPsec tunneling, right? So what we're going to do here is we're going to enter the SNMP community name and the IP address, which could be IPv4 or IPv6 address for that SNMP server. And then we're going to click apply, which is right here at the top. The WLC will now forward SNMP log messages to that SNMP server. So remember from our previous slide, this is our SNMP server right here. So WLC is now going to be forwarding that SNMP log messages to that server because we have configured that information right here. Configure radius server information. To configure the WLC with the radius server information, we're going to go to this top tabs and we're going to select now the security tab this time. So on the security tab, once you click on it, on the left hand side, you're going to have the radius main menu. And when you click on it, it will expand the radius menu submenus. On the submenu, we're going to select authentication, and that will give us this page. And in here, currently we don't have anything configured, so we're going to create a new one by clicking new to add that PCA as a radius server. So we're going to add the PCA now as a radius server by clicking new. So once you have clicked new, you will be greeted with this screen. And what you need to do is to enter the IPv4 address for PCA and the shared secret that will be used between the WLC and the radius server, and then click apply. So you have the server IP address, so which is the PCA in our diagram in this example, and we're going to enter the shared key information, and then we're going to leave the port numbers and other information at default, and we're going to apply the configuration. So after you clicking apply, the list of configure radius authentication servers will refresh and the new list will be shown here. So in here right now, we have that one that we just created shown on the list of radius servers on this WLC. And again, I will go through these labs on a live lab demo on a separate video and post to my YouTube channel later. There's another video called Configure a VLAN for a new WLAN in your Cisco NetAcad. You can either access to Cisco NetAcad or through your academic institution to watch this video. But however, if you do not have access to this video, I will post a copy of this video to my YouTube channel, and I will leave a link in the description of this video, as well as I will post a card on the top right hand corner so that you can click on it and watch that video. Topology with WLAN 5 addressing. Each WLAN configured on the WLC needs its own virtual interface. So remember, we have this network diagram previously. This is the example we are using right now. So each WLAN configured on the WLC needs its own virtual interface, right? So the WLC has 5 physical data ports that can be configured to support multiple WLANs on the virtual interface. The new WLAN will use the interface WLAN 5 and network 192.168.5.0/24, and therefore R1 has been configured for WLAN 5 as shown in the topology here. So we can run the show IP interface brief on your router right here, and that will give you that information. So it's showing the WLAN with the WLAN 5 and the subnet network of 192.168.5.0/24 configured accordingly. So remember from our previous lectures, show IP interface brief command. So that's what we are using right here to display that information. Configure a new interface. WLAN interface configuration on WLC includes these steps, and once you do them, you can create those new interfaces. So first thing we're going to do, create a new interface. Then we're going to configure the WLAN name and ID. Then we're going to configure the port and interface address. And then we're going to configure DHCP server address. Finally, we're going to apply, confirm, and verify those interfaces. So the next few slides, we will go through them with some demonstration pictures. So the first thing we're going to do, we're going to create a new interface. To do that, from the top tabs, we're going to select controller, and on the left hand side, we're going to click on the menu item called interfaces. And in here, you may already have some interfaces, such as the management interface, already listed on your WLC. In fact, you should have the management interface listed on here on the controller anyway, because that's how you access your WLC. On the top right hand, you have the option called new. Again, we're going to click that new button to create that new interface. And you can, in this example, we are using the interface name WLAN 5 and WLAN ID 5. Again, you can name whatever the interface you like, but typically as network administrators and system administrators, we usually associate the interface name with the WLAN ID. So in this case, we are using WLAN ID number 5. So we are naming the interface name as WLAN 5 so that it is easier for us to identify, or it is easier for the next person who come and check this, to identify it. Next thing we're going to do is to click apply button on this here on the top right hand corner. We're going to click apply, and that will apply that new interface configuration. Next thing we're going to do is to configure the port and the interface address. On the interface, edit page, configure the physical port number. Example, WLC G1 interface is port number 1 on the WLC. The WLAN 5 interface addressing, in this case 192.168.5.254/24, and the default gateway 192.168.5.1. So these are all configured right here under the interface edit options. So basically, once you have created this interface, within that interface, you have these options you can modify, such as the port number, IP address, net mask, subnet mask, and the gateway information associated with that. So that's what we are doing here. And then next thing we're going to look at is the DHCP server. So the DHCP server address in here, we're going to have this 192.168.5.1 because that's the example we are using. Or you can set up to whatever the DHCP server IP address you have for your situation, but in here that's what we are using, and that's would be entered right here. And finally we're going to apply and confirm, and when you hit apply, you will get a warning message saying changing the interface parameters cause the WLAN to be temporarily disabled and thus may result in loss of connectivity for some of the clients. That is just basically giving system administrators and network administrators a warning saying, hey, what you're about to do may have an impact on your users. So do you really want to proceed? And in this case, we're going to say, okay, that will save the configuration we just made. Finally, what we're going to do, we're going to verify the interfaces. So to do that, again, within the controller tab, click on the interfaces to verify that the new WLAN 5 interface is shown in the list of interfaces with its IPv4 addresses. So under controller tab, under interfaces, you will have the list of interfaces such as the management interface, for example. But now you have that newly created interface, which is WLAN 5. If you want to edit this WLAN 5 after creation, you can click on this WLAN 5. It will get you back to that edit pages where you can change some configuration settings the same way we have done right here. It will get you to these pages. There's a video called Configure a DHCP Scope. It is available on your Cisco NetAcad or through your academic institution. Again, if you do not have access to these videos, I will leave a link in the description of this video so that you have a way to watch that. I will also leave a card on the top right hand corner so that you can click on that and watch that as well. This will cover some of the items that I will go through in the next few slides. So how do you configure a DHCP scope? So the DHCP scope is similar to that of a DHCP pool on a router, right? So the DHCP scope can be configured by creating a new DHCP scope, naming the DHCP scope, verifying the DHCP scope, and finally configuring and enabling that DHCP scope. After that, you can verify the enable DHCP scope on your WLAN. So next few slides, that's what we're going to cover with some example screenshots. So the first thing we're going to do is to create a new DHCP scope. To configure a new DHCP scope, we're going to click Internal DHCP Server. So under the Controller tab, on the left-hand side, you will have the option called Internal DHCP Server. And that will expand some submenus, and one of them will be DHCP scope. So we're going to click on that. Next, what we're going to do, we're going to select new to create a new DHCP scope. So the first thing we're going to do, we're going to name that DHCP scope. We're going to ask what name should this DHCP scope have. So in this case, we're going to name it wireless_management. So that's what we have here. And once you click apply, so if you go back, sorry. So next you need to click apply here. So once you click apply, you will be greeted with this page where it will be listing all the DHCP scope. So the one we just created shows wireless management, and the pool is pretty much 0 now because we haven't done any configurations. So in the DHCP scope page, now you have that listed. You can now configure and enable the new DHCP scope. So on the edit screen of the wireless_management scope, which we just created, how you're going to access that is basically clicking on this link. So you click on the DHCP scope name, and that will get you to the edit screen, as I mentioned before in the previous examples also. And now you can create this DHCP scope configuration. In here, we have the DHCP pool start address, which is the 192.168.200.240, and we have the pool ending address, which is 192.168.200.249. So there's about 9 IP addresses within there. Then we're gonna enter the network information. We're gonna enter the net mask information, and then we're gonna enter the default router information, and also whether you're gonna enable this right now or we're gonna just save it as a configuration to be enabled later. In this case, we have entered the information based on our network topology that we are looking at previously, and now we're gonna hit apply. So that will gonna enable this this DSCP scope in this WLC. And finally, what we're gonna do, we're gonna verify the enable DSCP scope. The network administrator will be returned to the DSCP scope page once you apply the changes, and can verify the scope is ready to be allocated to new WLAN on that scope page, because it is now being listed with that pool addresses associated with that DSCP scope. Again, I will go through this on a live lab demonstration and post to my YouTube channel in a separate video. For now, just know these steps and how you can go through them to configure the DSCP scope. There's a video titled Configure a WPA2 Enterprise WLAN on your Cisco NetAcad site or through your academic institution. If you do not have access to this video, again, I will post a link in the description posted to my YouTube channel, as well as I will put a card on the top right hand corner. It will cover the topics that we're going to be covering in next few slides, and it will give you a better idea about the topics that we cover. Configure a WPA2 Enterprise WLAN. By default, all newly created WLANs on WLC will use WPA2 with Advanced Encryption System, also known as AES. 802.1x is the default key management protocol used to communicate with the radius server. Remember from my previous lecture, I have also mentioned this, that IEEE 802.1x standard is what we're going to use to communicate with the radius server. Next, create a new WLAN to use interface VLAN 5, because that's what we're using in this example. Okay, so it's not something that you have to always do, it's something that we use in this example, VLAN 5. So the configuring a new WLAN on the WLC includes these steps: create a new WLAN, configure the WLAN name and SSID, enable WLAN for the VLAN 5, because that's the VLAN we're going to use, verify AES and 802.1x defaults, configure WLAN security to use radius server, and verify the new WLAN is available. And again, next few slides, I will go through these steps with some Cisco provided screenshots for these configurations. So the first thing we're going to do is to create a new WLAN. To do that, we're going to click on WLANs tab from the top right here. We have the WLANs tab, and then we're going to click on Go to create the new WLAN. So click on WLAN tab here, and on the main page you will see create new, and then in here we're going to click on Go. So then what we can do, we can configure the WLAN name and SSID on the next page after you click Go. So in here we are configuring the profile name as company name, and we're going to give the SSID as company name. Again, to keep it consistent, I would usually pick the same profile name and as the SSID. In this case is company name and company name, and we're going to give the ID of 5. So because we are using, VLAN 5, right? So that's why it has to be, this ID doesn't really have a major impact on with what VLAN number you use, but in this case we're going to use VLAN 5 because to keep it consistent. Next, we're going to click apply button on the top right hand corner right here, and that will get you to the next page. And on this page, the we're gonna enable the WLAN for VLAN 5. So once the WLAN has been created, change the status to enable. So we're gonna change the status right here to enable. So now the one that we have just applied, we're gonna enable it, and then choose VLAN 5 from the interface groups drop down, because we already have created VLAN 5 in the previous previous steps. And then we're gonna click apply and click OK to accept on this pop-up. So we're gonna enable it, and then we're gonna select the VLAN 5. Then we're gonna click OK, and then in this pop-up we're gonna click OK because it's just a warning. So next thing we're gonna do is to verify AES and 802.1x defaults, right? So to do that, we're gonna click on the security tab. So within the this section, within the WLAN tab, we have gone through the previous steps of creating a new LAN, and we have given a name, and we have set up all of this. We have enabled it, we have attached that to VLAN 5, we have applied. But now within here, there's few other tabs. So one of the tabs is called security. So we're gonna click on security tab, and under layer 2, because this is a layer 2 option, we're gonna make sure that we have the AES selected, and we have IEEE 802.1x standard enable right here. And then what we're gonna do, we're gonna configure the radius server. So under the same security tab, we're gonna now click on we will now click on AAA servers. So on the AAA server sub tab, we're gonna configure the AAA server information. In this case, we're gonna select the AAA server information that we have configured previously on our previous steps here. And we're gonna enable it. We're gonna make sure the authentication accounting enable. And then we're gonna hit apply. We're gonna select apply. So that's gonna apply that configuration. And once you do that, your page is gonna get refreshed onto this page. So now you can verify the new WLAN is available. And to verify that information, we're gonna click on the WLAN submenu, and that will have the listed information we just created right here, the company name and WLAN, and you see the authentication information right here with 802.1x with the WPA2 on the security policy area. So there is a packet tracer file called configure a WPA2 enterprise WLAN on WLC, which will go over the information that we briefly covered in our previous slides. I will do these packet tracer files on a live video demo and put it onto my YouTube channel later. But for now, if I find this packet tracer file, I'll post to my website so that you have a copy of it so you can practice yourself. So I would recommend that you go through these packet tracer files every single time you cover a topic, and there is an available file for you to do, because it will enhance your understanding of concepts that we have covered. Troubleshoot WLAN issues. Troubleshooting approaches. Network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. Troubleshooting any sort of network problem should follow a systematic approach. A common and efficient troubleshooting methodology is based on scientific method and can be broken into 6 main steps shown in the table on the next slide. So here's the table that the previous slide is referring to. So we have steps listed on the left hand side. We have a description and the title on the right hand. So the very first thing we need to do is to identify the problem. So in this first step, the troubleshooting process is to identify what's going on and what's the problem. And while the tools can be used in this step, a conversation with the user is very helpful. So as a network administrator, it also could be a conversation with your managers, supervisors, or other network technicians who are experiencing these issues. Then we're going to establish a theory of probable causes. So after you have talked to the user and identified the problem, you can try and establish a theory of probable causes, and this step often yields more than a few probable causes for many problems that you will encounter. So the next one we're going to do is to test the theory to determine the cause. So based on the probable causes, so based on the previous steps, you can test your theories to determine which one is the cause of the problem. A technician will often apply a quick procedure to test and see if it solves the problem. If a quick procedure does not correct the problem, you might need to research the problem further to establish the exact cause. So the next step going to be to establish a plan of action to resolve the problem and implement the solution. After you have determined the exact cause of the problem, you need to establish a plan of action to resolve the problem and then implement that solution. Finally, we need to verify full system functionality and implement preventative measures. So after you have corrected the problem, verify all the functionality, and if applicable, implement preventative measures. And in a good network system environment, in a good company, in a good organization environment, you should also have some kind of a procedure for documenting findings and actions and outcomes. So in this final step of troubleshooting process, based on your company policies, you should document your findings, actions, and outcomes. This is important for future references. But however, unfortunately, in many small businesses and also even some large corporations and companies, I have seen that they don't have that final step number 6 implemented. So if you are implementing a system and you are in charge, especially of that network system, I would certainly implement all these 6 steps and would not skip the document part, even though it is something oftentimes omitted by a lot of organizations. So documenting is as important as solving the problem. So here are some examples of few troubleshooting issues. So in this one, the wireless client not connecting. So if there is no connectivity, check the following. Confirm the network configuration on the PC using the ipconfig command. Confirm the device can connect to the network. Ping a known IP address. Remember, in my previous lectures, I have mentioned ping and traceroute are 2 types of commands that we use a lot in network troubleshooting, and that's what exactly we are doing here. So we are using ping in this case. So if needed, reload drivers as appropriate for the client, or try a different wireless network interface card. So maybe there's a problem with the driver with your Intel network card trying to communicate to your Cisco switch or router, for example. If the wireless network interface card of the client is working, check the security mode and encryption settings on the client, because there are different security modes and there are different encryptions, and if they're not compatible between your wireless access point and your end device, it won't be able to communicate. If the PC is operational but the wireless connection is performing poorly, check the following. Is the PC out of the planned coverage area, also known as BSA? Check the channel settings on the wireless client, whether there are overlaps or there are issues, and check any interference with the 2.4 gigahertz band, because there are a lot of devices nowadays that use 2.4 gigahertz band, including microwaves. So you need to check those things. So in this case, the user have connectivity to the network, but it is either too slow and performing poorly, or connectivity get lost very often and user has to reconnect every few often. So that would be an issue with the performance, even though the user has a connection, and this could be the reasons why that happened. So the next thing we're going to do, we need to ensure that the devices are actually in place. So consider the possible physical security issues. This could be that some threat actor disconnecting a network device. That could be an access point, or somebody physically destroying your access point. That could be another reason. I don't know, like a student in your campus environment throw I have seen that actually, throw some book or something across the table, or across into the ceiling tile, and you have access point underneath the ceiling tile, or on the ceiling tile, that get damaged, for example. That's one thing you should consider: the physical damage, physical security, physical threat actor, or accident. And also you should check, is there power to all devices and they are powered on. A quick note on power: there are situations in some manufacturers have access points that would show the power is coming on, but they don't have enough power to power the access point to full capacity. So it will be like doing a poor coverage. So let's say you have a device that needs 5 watts, but it's getting 2 watts. You may see a light blinking, but it probably not fully powered on. Because I seen some manufacturers, I won't mention any names, but there are some manufacturers, the access point will show like, oh yeah, it has power, it's kind of on, but it's not really fully turned on. All the antennas are not on, because reason that it doesn't receive the full power that it requires. So not only do you need to check those access points and WLCs and everything else have power, but you also need to check whether the power is properly being received by that end device. A very good example of this is a cable length. So Cat5e has a length that you can carry that power over that cable. So if you have just one or couple of few meters away from the maximum length, the access point can keep power on and back and on and off and on and off, or have lower power. So you will see the power being received, but it may be low because the length of the cable is too high, or something like too long, or something like that. So make sure it's not just whether the devices have power, but devices have enough power, and the devices are provided with correct power input. If it is requires 5 watt, it requires 5 watt, not 2.5 watts, right? So that need to be checked as well. So finally, inspect links between cable devices looking for bad connection or damage or missing cable. And also another thing I just added is the cable length. So make sure that it is properly allocated and properly done. So if the physical plant is in place, verify the wired LAN by pigging devices, including the access point. If connectivity still fails at this point, perhaps something is wrong with the access point or its configuration. When the user PC is eliminated as the source of the problem and the physical status of devices is confirmed, begin investigating the performance of the access point. That's where I mentioned the low power for the access point. So check the power status of the access point, the power range for the access point, the cable length, etc., come into play at this point. Troubleshooting when the network is slow. To optimize and increase the bandwidth of 802.11 dual band routers and APs, we have to either upgrade your wireless clients or split the traffic. So older 802.11b, 802.11g, and even 802.11n devices can slow the entire WLAN. For the best performance, always it is recommended to use all wireless devices that support the highest acceptable standard. So the best option you have is actually to upgrade your wireless clients, but that is not always possible. So the other option is split the traffic. This is an easier way to improve wireless performance by splitting the wireless traffic between 802.11n, 2.4 GHz band and the 5 GHz band. Therefore, 802.11n or better can use the two bands as two separate wireless networks to help manage the traffic. And you should also know there are several reasons for using split traffic in addition to the one that just described here. The 2.4 gigahertz band may be suitable for basic internet traffic that is not time sensitive. The bandwidth may still be shared with other nearby WLANs. The 5 GHz band is much less crowded than the 2.4 GHz band, therefore it is ideal for streaming multimedia. And the 5 GHz band has more channels, therefore the channel chosen is likely going to be interference free. So it's not a guaranteed interference free, but most likely going to be interference free. By default, dual band routers and access points use the same network name on both 2.4 GHz band as well as the 5 GHz band. It may be useful to segment the traffic. The simplest way to segment traffic is to rename one of those wireless networks with a different name. So for example, you could have Sanuja Net 2.4 and Sanuja Net 5 GHz 5. So that way, when I try to look for the SSID, I have two different distinct SSID for 2.4 GHz band as well as the 5 GHz band. And then depending on my device, I may be able to pick either or connect to one of them. To improve the range of the wireless network, ensure the wireless router or AP location is free of obstructions such as furniture, fixtures, and tall appliances. So these block the signal, which shorten the range of the WLAN. If this still does not solve the problem, then a Wi-Fi range extender or deploying the power line wireless technology may be used. But in addition, another example of an issue that I have seen is installing an access point or a wireless router right behind or right next to a microwave oven. So if you have an office with a area for eating food, a lunchroom, and if you put a wireless access point right next to a microwave oven, there is a possibility that 2.4 gigahertz band especially going to have some interference as a result of it. So I have seen that as well. In hospitals, there are situations where there are some medical equipment that use wireless communication on the 2.4 or 5 gigahertz bands that may interfere with those wireless access points within the hospital building. So that's another example of interference. So you need to look at also not only just the location of the access point or the wireless wireless router in terms of furniture, fixtures, and tall appliances, but also other devices in the vicinity or in the building that may be interfering with your wireless network. Updating firmware. Most wireless routers and access points offer upgradable firmware that should be periodically verified. On a WLC, there will most likely be the ability to upgrade the firmware on all APs that the WLC controls. Remember, the primary purpose of having a WLC is also, one of the primary purposes is the central control. So upgradability of your multiple APs that is connected to this single WLC is another advantage of having that WLC control APs, right? As opposed to autonomous APs, which we discussed previously. So in the figure on the right hand side, the firmware image that will be used to upgrade all the APs is downloaded. On Cisco 3504 wireless controller, you can go to the wireless section from the about tabs up here and go to access points on the left hand side menu. On the access point submenu, you can click on the submenu item global configuration and then scroll to the bottom of the page for AP image pre-downloaded section. And from there, you can upgrade your the AP's firmware. There is a packet tracer file called Troubleshoot WLAN issues, which is available to you through the Cisco NetAcad or through your academic institution. If you do not have access to these files, I will try to find a copy of this file and post to my sanuja.com website, and that will go over some of the concepts that we have covered. And that is the end of this lecture, and now I will go over a summary of what we have covered. There is another packet tracer file called WLAN configuration, which also cover everything that we went over in this module, and you should be able to download it through Cisco NetAcad, or I will find a copy and post to my website so you can have a comprehensive idea about everything that we have covered. So here is a summary of what we have covered in this module. We learn remote workers, small branch offices, and home networks often use a wireless router, which typically include a switch for a wired client, a port for an internet connection, sometimes labeled as WAN, but also sometimes labeled as internet, literally, on the back of the port, and the wireless components for the wireless client access. We learn most wireless routers are pre-configured to be connected to the network and provide services. The wireless router uses DHCP to automatically provide addressing information to connected devices. For your first priority should be to change the username and password of your wireless router. So as soon as you get the wireless router or even a wireless access point out of the box, the first thing you should be changing is the username and password associated with it. If you want to extend the range beyond approximately 45 meters indoors or 90 meters outdoors, you can add wireless access points. These are additional access points. The router will use a process called network address translation, also known as NAT, to convert private IPv4 addresses to internet routable IPv4 addresses. So we learned that not only that's the purpose of the NAT, but NAT was actually one of the solutions for IPv4 address exhaustion until we came up with this IPv6 idea, right? So that's another reason why we have that. So this way we will still have those limited number of IPv4 addresses for global routes, and then we will have the local IPv4 addresses separated from those IPs. By configuring QoS or quality of service, you can guarantee that certain traffic types such as voice and video are prioritized over traffic that is not as time sensitive, such as email and web browsing. And we learn why this is important as a high level overview. We also learn lightweight APs, also known as LAPs, use the lightweight access point protocol, also known as LWAPP, to communicate with a WLAN controller, also known as WLC. In this module, we also learned configuring a wireless LAN controller. WLC is very similar to configuring a wireless router, except that a WLC controls APs and provide more services and management capabilities. We use the WLC interface to view an overall picture of the APs, system information and performance, to access advanced settings and to configure WLANs. We learn a little bit about SNMP and how it is used to monitor the network. The WLC is set to forward all SNMP log messages called traps to SNMP server. For WLAN user authentication, we learn about the Radius server can be used for authentication, accounting and auditing, also known as AAA services. And individual user access can be tracked and audited through that Radius server. We use the WLC interface to configure SNMP server and Radius server information, VLAN interfaces, DHCP scope, and WPA2 enterprise WLAN. We learn about how we can do that on a Cisco device. There are 6 steps to troubleshooting process, and we have list them on a table for you. And when troubleshooting a WLAN, a process of elimination is recommended. Common problems are no connectivity or poorly performing wireless connection when the PC is operational. To optimize and increase the bandwidth of 802.11 dual band routers and APs, either you can upgrade your wireless clients or split the traffic. And we learn about the differences between the two. We also cover that most wireless routers and APs offer upgradable firmware And the firmware releases may contain fixes for common problems reported by customers as well as security vulnerabilities. You should periodically check router or AP for updated firmware, because those firmware do comes out very often. It's not necessarily a specific period of time, but as soon as there is a firmware upgrade, you should be looking into updating your devices. This will improve your security and patch some vulnerabilities. If you like this lecture, please thumbs up this video and subscribe to my channel. If you have any questions or concerns regarding any of the items that we have covered, please don't hesitate to reach out to me. I will make sure to go over the items that we have covered in real life lab demonstration and post it onto my YouTube channel. Good luck and have a nice day.